video, I'd like to walk you through an example of using the simplex method to maximize a problem with constraints in the form of less than or equal to. Now, I'm going to warn you before we start this video that this is not a simple problem, even though it's called the simplex method. If you've struggled with this problem at all, don't feel like you're behind in any way. This is a really involved problem. But there is a method of getting really, really efficient at this problem, and that method is practice. If you'll practice this example in the video and then several others in your homework set, or if you still are not feeling competent, then try some additional problems that are available in your textbook. The goal is not to just finish a set of homework problems, but rather to feel competent, to truly grasp how to use a simplex method. For some students, it'll only take one time through. For others, it'll take 2 or 3 attempts. And for some of us, it'll take 4, 5, 6 practice problems before we really feel like we can understand this process. So if you're here because you truly want to grasp using the simplex method, then I want to encourage you to practice as many times as you need to. Watch this video and then try the example in this video without any notes and see if you can get to the same correct end result. But one last thing I'm going to say is many students are using this problem because you're in a math course that's a prerequisite for a business program. And let me explain that if you get to that point in your academic career where you're working on a degree such as a master's degree in business administration, an MBA, then you'll eventually be doing many of these problems, but you'll be doing this with a computerized program. So as you might imagine, once we start this problem, you might start thinking, couldn't a computer do this much more efficiently? And yes, you are absolutely correct that a computer can generate the result of this problem much more quickly and efficiently. However, the importance here and why we're going back to the rudimentary solving this problem with paper and pencil is because when you get to that point where you're using a computer to spit out a result, you still need to understand what it is that the computer did so that you could still be successful doing that problem without that technology. But let's get started on this problem. In our textbook, if you're a student in our current semester course of Finite Mathematics, then this is section 6.2, and it's an example of the simplex method. So what we have is a function that we want to maximize. We want to maximize profit, or P, equals 18x1 plus 20x2 plus 32x3, and we have these 3 constraints. I'm not going to read them, but they're the 3 subject to inequalities that we see here. And we're going to start by just stating that our variables are all going to be non-negative and not equal to 0. So in other words, our x1, x2, and x3 are all going to be positive. So the first step is to write our objective function. That's our what we're wanting to maximize, our P equation, as something set to 0, so that we have all of the variables, including this P, on the left side of the equal sign. So we could do that with an easy algebra of subtracting 18x1, subtract 20x2, subtract 32x3, and we'd be left with a 0 on the right, and we'd have P minus 18x1 minus 20x2 minus 32x3 all on the left. That's our first step. The second step is to convert our three inequalities into equations. And the way that we change our inequality into an equation is by introducing what we're going to call a slack variable. It's a slack variable because it's taking up the slack. Now, if we look back here at our inequality, can you imagine that if x1 plus 2x2 plus 2x3 is less than 22, then if we wanted it to equal 22, we'd have to add some amount here. Remembering that our x1, x2, and x3 are all non-zero and non-negative. They're all positive. You could see that we could add some value, and we're going to call that S1 for slack variable 1. We can add that value to those three pieces, and that converts this inequality into an equation. So that's what this S1 is. We can do the same for our second equation. We're going to introduce a second slack variable. It's a different variable than S1 because it might or might not be different, but we can't assume that S1 and S2 are the same. The amount of slack to get this set of terms up to 40 might be different than what we needed for the blue equation. And then we do the same for the orange equation. So you see what we've done is we've introduced three slack variables, S1, S2, and S3. Now that I have four equations, I'm going to write those into our table. And this should now remind you of the work we did with matrices and the Gauss-Jordan elimination. But all I've done here is I've put our P equation down here in the bottom. So our P equation, the x1 variable is negative 18, x2 is negative 20, x3 coefficient is negative 32. There's 0 for slack 1, 2, and 3 because we didn't have a slack variable. And P is equal to 1. And then our equals to at the end after the equal sign was 0. So we have this green 0 here. Notice I've transferred our blue, purple, and orange equations in also by carrying over their coefficients. 1, 2, 2, 1. And then the S2, S3, and P are all coefficient of 0. 3, 2, 4, 1. And the S1, S3, and P all have a 0. 3, 1, 2, 1. And the S1, S2, and P all have a value of 0. And now we're ready to move towards changing this around, just performing some row operations with a goal of getting rid of all these negatives. Everything in this last row here has to be non-negative. So you could pick any column to start with. You could pick anywhere to start, but if you want the most efficient method, if we're trying to eliminate negatives here, we're trying to eliminate the negative in the 18, the 20, and the 32, it's going to make the most sense to start in this column that has a 32 because that's the most negative. So because that negative 32 is the most negative value in the last row, we're going to select the X3 column as our pivot column. That's the pivot column. If you reflect back to the Gauss-Jordan problems, remember that we made a 1 and then we bounced off of that 1 to get zeros. Well, what we need to determine is where do we want our 1? in the blue, purple, or orange value element. And the way that we determine where we want our 1 is first we select a column. We selected the column based on which of these values in the last row was the most negative, and that was a 32. And then what we do is we take each of our last, now we're trying to determine, is it the blue 2, the purple 4, or the orange 2 that we're going to pivot from or bounce off of. And the way I determine that is I take the end column, the 22, 40, and 14, and divide them by their respective column x3 term. So I'm going to do this 22 divided by 2, 40 divided by 4, 14 divided by 2, and I get an 11, 10, and 7. Of course, when I do a 0 divided by, I'm going to get a 0. So we don't really even need to do that one. I just wanted to show it in the case that someone had a question, well, why didn't we consider that negative 32? Well, out of these 3, we have a winner, and that's the 7. The 7 is the smallest quotient. So what does that tell us? It tells us that we want to pivot from the orange 2. Let me walk through this one more quick time just in case I lost anyone. We're trying to determine where in all of this table, where do we want to get our 1 to bounce off of? Our goal is to turn all of these values in the bottom row to positive. And we're going to do that by getting a 1, and it's going to be one of these 9 elements here. We need to get one of these 9 elements into a 1 and bounce off of it to create zeros above and below it. And if we do that, we're eventually going to get rid of all the negatives down here. How did I choose this orange 2? Well, I found first out of the 3 columns that the 32 is the most negative. So I knew I was going to use the column x3. How did I choose row s3? Because when I divided each of the last columns by the column x3, the smallest value came out as 7. The smallest quotient is 7. So I knew to use this orange 2 as the pivot. But let's move on to what we're going to do with the pivot. I'll turn the page here, and here's just a copy and paste of what we had on the last page. Here's our pivot that's highlighted, our 2. So what am I going to do now? I'm going to use that 2 to get zeros everywhere else. I want to change this 2, 4, negative 32 into zeros. And how am I going to do that? I'm going to get my pivot into a 1. That's easy. I'll just multiply the 3, 1, 2, 0, 0, 1, 0, 14, multiply them all by 1/2. Or in other words, I take this row S3 and divide it by 2. Now, by the letter of the law, you're not allowed to divide. Dividing isn't a row operation. And I did just say divide. But officially, what we're doing is multiplying by 1/2. But it's the same thing as dividing by 2. So I hope you're not offended by me saying we're going to divide this row by 2. But just keep in mind that really what we're doing, so we don't break any laws, is what we're really doing is multiplying by 1/2. But I'm going to take the 3, multiply by 1/2, 1 times 1/2, 2 by 1/2, and so on. And here's what I get. The resulting column is 3/2, 1/2, 1, 0, 0, 1/2, 0, and 7. Now, the big deal about that is that I was getting this 1, my pivot, into a 1. Once I have this 1, I can bounce off of that 1 to change the 4 to a 0. I can bounce off of the 1 to change the 2 to a 0. I can bounce off of the 1 to change the negative 32 to a 0. And how I do that is I'm going to multiply my row by 4, or negative 4 rather, and add it to the purple 4 to get a 0. So if I do a -4 times my new row 3, I'd get -6, -2, -4, 0, 0, -2, 0, -28. All I did was I took this orange column, cut it in half, and then now I've multiplied it by a -4 to get these numbers. I'm going to add it to my purple row, 3, 2, 4, 0, 1, 0, 0, 40, to get a new row 2. -3, 0, 0, 0, 1, -2, 0, 12. And now onto the blue row, S1. I'm going to again bounce off of this 1, my pivot, to turn this blue 2 into a 0. I can do that with the help of a -2. I'll multiply my new row 3 by -2 and add it to row S1, and I get a new row 1 of -2, 1, 0, 1, 0, -1, 0, 8. And then last but not least, doing that to the last row, the P row, I'd get a 30, -4, 0, 0, 0, 16, 1, 224. Now, if that arithmetic is a little slower for you, I'm going to encourage you to pause the video and go back and calculate those values. Make sure you're able to calculate those new rows yourself. But all I've done here with this blue ink is I've just rewritten the new rows. So I've got my S1 row is -2, 1, 0, 1, 0, -1, 0, 8. The S2 row is here, -3, 0, 0, 0, 1, -2, 0, 1, and 12. And the S3 row is the row we got by multiplying by a half. And then our P row is the one starting with a 30. So we have this new matrix, and I've just copied and pasted that matrix onto a new page in my notebook. And unfortunately, we're not done yet, because we're going to ask, wait, am I done yet? No, we're not done, because we have a negative. Oops, sorry, I'm going to change that picture if I'm not careful. We've got a negative still in this last bottom row. So because we have a negative here still in our pivot row, our last row, we can't say that we're finished yet. We haven't fully maximized this value down here yet until we've gotten rid of all the negatives. So it looks like we've got to go again. When I look at the values down here, the only one that's negative is the 4. So I know that X2 is going to be our pivot column. And I'm going to use the top one, the top row, as the pivot value or the pivot element, because when I divide each of the elements in the last row, or I'm sorry, I should say column, the last column, the 8, 12, 7, 2, 24, divided by the X2 column, 1, 0, 1 half, -4. When I find those quotients, I get an 8 and a 14, and the smallest is the 8. So I'm going to use this 1 as a pivot. A nice thing about that pivot is that it's already a 1. We don't have to do anything. We don't have to multiply by a fraction to change it into a 1. It's already a 1, and we're ready to go. So I'm going to copy that matrix over again. Notice that I've circled our pivot. What are we going to do now? We're going to bounce off of this 1 to change the 1 half into a 0, because this value already is a 0. We've got to change this 1 half into a 0, and we've got to change the -4 into a 0. I can do that by adding -1 half times row 1 to row 3. And then I can do negative or positive 4 times row 1 plus this p row, row 4, to get these new rows. And you see what I've done is I've taken these 2 rows and replaced them up here. So this is our new row 3. Here's our new p row, row 4. And I now have a new matrix. Feel free to pause the video and work out the arithmetic if you're not confident yet in where I got the values in the table. But now we want to see, are we done yet? And you might feel like you've got the donkey from Shrek in the back seat of your car. Are we there yet? Well, back on this page, we were asking, are we there yet? Are we finished? No, we're not there yet because we still had a negative in the bottom. Are we there yet? Yes, we're finally there, because if you look at the bottom row, our P row, you'll see that there are no negatives. So because there are no negatives, we can say we're finished. And what does this tell us? You'll notice that I used darker ink for this 256. What it tells us is that the final answer is 256. If we maximize, going back to, let's turn the page here. If we want to maximize P, the maximum P possible is going to be 256. How do we get a P with a value of this highest number possible? We're going to get it by, let's go to our last table here. We get a P of, let me go to that, 256 when x1 is 22 and x2 is 0 and x3 is 0. And we have these slack variables of 4, 0, 12, and a P of 1. But 256 is the maximum value we'll get with this set of constraints. And that's it. I hope that you find this video helpful. And please, if you do have questions about the process or about any of the steps I've done in the video, please let me know. I'd be happy to try to answer any of those questions or fill in any gaps that you still have.